Hi students, welcome back to my channel. I am Sushma. Today we are going to learn class 11th chapter 1 sets. And in that last time we solved exercise 1.2 introduction and we solved the examples and exercise. Now we are going to start up with the introduction to exercise 1.2. Here we have a first definition is empty set. Otherwise, we can call empty set as a null set, or we can call that as a void set. That means we don't have anything in that representation. That is the meaning of that. That means it won't exist. That means it won't contain anything in it. So what is the answer we have for this? The set which does not contain any element. So that we will call as a empty set, and we will denote this one. We will denote this by pi. Otherwise, we can do like a empty set. That means this one and this one both also you can write anyone, it's correct, but you can't join both and you can't write this. This is wrong. You can write like this, otherwise like empty set. This is empty set, this is a pi. So you can write in this both anyone to denote the empty set. And now we have a example for this. So I'll take a is equals to x is to x is an natural number greater than 5 and less than 5. You can observe here, they said a is equals to x defines x is a natural number. That means 1, 2, 3, 4 like that. That is greater than 5. That means which number is that is greater than 5 and less than 5. Because greater than 5, less than 5. It won't exist, is it right? We have a 5 here means greater than, less than means it will come here only. But it can't be because they are mentioning less than and more than. So therefore it's an empty set. We can't get any solution. That means we can't get any set for this. So therefore we can write the answer is a is equals to pi. That means it won't exist. That's the meaning. So next I'll see another example for this. b is equals to x is to x square is equals to 4 and x is odd. You can observe here, they said x defines x square is equals to 4. So now we solve for x square is equals to 4. What we'll get? X square is equals to 4. By solving we will get plus or minus 2. Is it 2 is an odd number? No, 2 is not an odd number. It's an even number. So therefore we can say b is equals to pi because it's an even number, but they are telling x is odd number, so it won't exist. Therefore b is equals to pi. Next another one also I'll give an example. You can get to know that. So next one, c is equals to x is to x is even prime number, prime number lesser than 2. So we know the prime numbers, it will start from 2, 3, 5, etc. But it will start from where? 2. And they are telling lesser than 2. This is 2. Lesser than this, nothing won't come. So therefore we can say c is equals to pi. Okay, next definition we have is singleton set. Singleton set. So that means in a set we are getting only one number, otherwise one alphabet. That means only one thing is existing. So that's what we call as a singleton set. So the definition for this is A set consisting of single element. It may be alphabet, otherwise it may be numbers, anything, is called singleton set. Example you want, so we can write the example. A is equals to x defines x. X defines x is prime number lesser than 3. So x defines x is prime number lesser than 3. That means lesser than 3 we need to get. So which is this lesser than 3 prime number? Because we start from 2, 3, 5 like that. Is it right? Which is the lesser than 3 we have? That is 2. That means only 2 that will exist. So like that. That means for example you have B is equals to something, only A you are getting. Otherwise few times you are getting a C is equals to only 0. So like that elements we will represent as a single element in a set. So that's we will call as a singleton set. So next definition, finite and infinite set. Finite means countable. Infinite means uncountable. That means till infinite it will exist. So that's what we say infinite set. So exact definition we need from in a mathematical way is finite set is sets containing countable number of elements are called finite set. Example you need, you can write, for example I take A is equals to 1, 2, 3, 4, 5 and it's closing. Is it we can count? It's not extending. Is it right? Therefore we can say it's a finite set. Another one example also I'll give. N is equals to 1, 2, 3, 4 etc. till 100. Is it this is also countable because they give a last number till where the numbers will exist. Is it it's starting in a 1, it's ending in a 100. In middle also numbers will exist, they are telling. So that means N is also finite set. Now we will see next one, infinite set definition. Infinite set. So infinite set, here we have a countable, but for this one uncountable. Sets containing uncountable number of elements are called infinite set. So example for this, I'll take this N only, but we won't end here. So therefore I'll get N is equals to 1, 2, 3, 4 etc. It's extending and going. It's not stopping anywhere. So it will extend till infinite. So therefore this one we'll say as a infinite set. Next one, equal set. Equal set means when two sets are exactly same. It's not even one, it can't be missing. Exactly same. They are said to be equal. That means if two sets are equal to each other, that means it has an exact number of elements. Otherwise it has exact numbers what we have in both the sets. So then only we'll say it's an equal set. So example you need means I'll take the example is A is equals to, I'll take 1, 2, 3, 4. Comma is must and should, you need to write in a set. Next B I'll take as a 3, 4, 1, 2. Is it we have both also equal? Now I let another one set also. See. 1, 4, 3, 2. We have same numbers, but it's misplaced, that's it only. But in a set, if misplaced also, we can take that's equal only. So if it's misplaced also, nothing is issue. So therefore, here you can see 1 is there. Here also we have 1. Here also we have 1. Next 2, 2, 2. Next 3, 3, 3. Next is 4, 4, 4. Exact all the elements we have. So therefore, we can say it's an equal set. So then how we will write that equal set? That is A is equals to B is equals to C. Otherwise, only two elements, they said 2. Say its equal sets or not, then you will write A is equals to B. So this is what the equal set. Now we will see the examples. Last time I stopped in examples 5. Now I'll start with examples 6. Okay, here we have an example. So example 6, find it's a finite or infinite. First one we have x is to x belongs to n, where x minus 1, x minus 2 is equals to 0. So let's solve this, that is x minus 1, x minus 2 is equals to 0 they said. So if we take an x minus 1 is equals to 0, x minus 2 is equals to 0, we will get x is equals to 1, x is equals to 2. That means what is the answer we are getting? That is 1, 2. So is it we can count this? So therefore it's a finite. So next one, second one, what we have? X is to x belongs to n, where x square is equals to 4. So they just said that it's a countable or not. We no need to represent in a form of plus or minus or all. Okay, if we take an x square is equals to 4, so we will get x is equals to plus or minus 2. That means plus or minus we are getting which one number? That is 2. So therefore what we are getting? The set, that is 2. So therefore we can say it's a finite, because we can count this. And another one also we can say, what is this? It's a singleton set. Is it right? Singleton set, because we are getting only 2. Therefore we can say this is a singleton set also. Next one we have 2x minus 1 is equals to 0. So if we take on one that side, what we will get? 2x is equals to 1. So x is equals to 1 by 2. Is it? But you can observe here in a question, they said x is to x belongs to n. N means what? Positive 1 only. Is it right? So that's why here also we taken only 2. We not taken plus or minus, because they said natural numbers. That means only in a positive side, which one it will exist, that only we can take as a n. So therefore we taken only plus 2. We not taken minus 2. So like that only here you can observe. If they said it belongs to n. So this set we need to have as a how? 1, 2, 3. Is it right? Like a numbers we need to have. But here we have a fraction. Is it? It belongs to n? So no. That means 1 by 2 won't belong. That means if 1 by 2 not there means, but then also it will exist in between 0 to 1. Is it right? That means 1 by 2 here somewhere it will exist. But we can't write here. So therefore what we can write? We can't directly write it's infinite. Is it right? It's a pi. It won't exist. We are not getting any elements, because we are getting 1 by 2, but it won't belongs to n. So therefore we will write this as a pi. So pi means, is it we can count? Yes. So therefore we can say it's a finite. Next one, they said x is to x belongs to n, and x is prime number. X is prime, they said. They not said from till where to where. Is it right? Prime number means it will start from where? 2, 3, 5, 7, etc. It will expand and go till infinite. So therefore what we can say? It's a infinite, because they not mentioned till where to where. So therefore it's an infinite set. Next one, x is to x belongs to n, and x is an odd number. They not said from where to where. Is it right? Just they said odd numbers. Odd numbers where it will start? 1, 3, 5, till it will extend and go. Is it right? Does it stops anywhere? No. Therefore it's a infinite. So once again I'll explain now. First one they said gave a equation, we solved, we got a x is equals to 1 and 2. So therefore we can say the numbers is finite. Next one we solved x square is equals to 4, we got plus or minus 2. But they only question mentioned that it belongs to n. We need to observe what they said. It belongs to n they said. Therefore only positive one we will take, that is 2. So therefore we can say it's a finite, and together with it's what? Singleton set also, because we are getting only one set, one number. So therefore next one, x belongs to x, where x is to ex belongs to en, and 2x minus 1 is equals to 0. By solving, what we got? X is equals to 1 by 2, but 1 by 2 won't come in our natural numbers. So therefore nothing is there, means we will write pi. Nothing is there, just mention it, pi. So pi means it's a finite only, so therefore we will mention this is finite. Next one, x is to ex belongs to n, and x is a prime number. Prime numbers from where to where they're not said. It won't end anywhere because it will extend and go till infinite. So therefore we can say it's an infinite set. So next one also they said odd numbers, it will start from 1 to extend and go, so therefore it's also infinite set. Okay, next example 7. Find the pair of equal sets if any given reason. That means in this we got any equal sets, means we need to give the reason also for that. That means which is an element commonly we have like that. So first one you can see we have a is equals to 0, so it won't simplify, so therefore we will keep it like that one. Next one you can say b is equals to x defines x greater than 15 and x is less than 5. How it will exist? Because they are telling it will be greater than 15, that means 15 above it will come. But here they are telling 5 less than 5, that means below that it won't come. Is it right? It won't exist. So therefore we can write it a 5. We can't simplify. So next one what we have, C. They gave that x defines x minus 5 is equals to 0. That means we have x minus 5 is equals to 0. By simplifying we got x is equals to 5. So therefore C we got 5. Next one we have x defines x, that x square is equals to 25. So by simplifying we'll get x is equals to square root of 25. So therefore we'll get x is equals to plus or minus 5. So therefore what we'll get? Plus 5 minus 5. Next one you can observe x is to x is integral positive root of the equation x square minus 2x minus 15 is equals to 0. First we need to simplify this, then only we can know that we can get any answer for this or not. So by simplifying, what is the equation we have? X square minus 2x minus 15 is equals to 0. So what is the terms we'll get for the 15, this one? So 5 3s are 15. So by subtracting 5 minus 3 we'll get 2. So therefore minus 5 plus minus 5x plus 3x minus 15. So in this 2 I'll take x as a common. I'll get x minus 5. Here in this 2 I'll take 3 as a common, plus 3. So then I'll get x minus 5. So we'll get x minus 5 as a common. So then what is the leftover? That is x plus 3 is equals to 0. Then we'll get x is equals to 5. Another one is x is equals to 3. We'll get 5 and 3. So therefore what we can write? Sorry, x is equals to plus 5 minus 3, because this 5 will go that side, it will become plus 5. This plus 3 will go that side, it will become minus 3. So therefore what we'll get? They said positive root. That means positive one, which one? Only 5 is there. So therefore this is 5. Now you can observe any sets equal to each other is there. First one we have 0. Is it we have anywhere? No. Next one we got pi, because we can't simplify. So therefore that one we don't have anywhere. See, you can observe we have 5. Is it anywhere we have 5? Yes, we have a E set also 5. So therefore we can write C is equals to E. D one also we can check, we have plus 5 minus 5. But we don't have only 5. I already said if it's equal set means equal numbers, equal elements need to be. But here one extra we have, that is minus 5. So we can't take it in account of. So therefore what we got? C is equals to E, because both also have a singleton element. What is that? 5. So therefore we can say this is a equal set. Okay, example 8. Which of the following pairs of sets are equal, and justify your answer. So first one question we have in this, X, the set of letter is alloy. You can observe here we have alloy, and B, the set of letter in lawyer. We need to check it's equal set or not. So first one I'll see what we have. First set, what they said, X is equals to what we have, alloy. So what are all letters we have? A, L, because we have 2 times L, so we will write only 1 time L. So small letter is there, small letter on L, right? L, O, Y. Is it right? That much only. Next one, what they said, set B. Is it right? B is equals to what we have, letters L, O, Y, A. L is there, but already we written one, so therefore that's it. Now we can observe, we have A here, A is there. L is there, L is there. O is there, O is there. Y is there, Y is there. So is it we have same elements there? So then we can say A is equals to B because it has the same elements. That is A, L, O, Y. So you can write that. Next one we have the set A is equals to N is to N belongs to Z, and N square less than or equal to 4. So N square less than or equal to 4 means N square less than or equal to 4. So that means if you simplify it, you will get square root of 4, that is plus or minus 2. So therefore we can say A set, what we are getting answer, that is, here one thing you need to observe properly. They said N less than or equal to plus or minus 2. We don't have equal, we have less than or equal to. Less than or equal to means, so it may be equal, it may be less than. That means here we have a minus 2 means here we have a plus 2. That means the number whatever it will exist, it will be equal to this, otherwise it will be between of that. That means it may be minus 1, 0, plus 1, anything. So therefore we need to write the what and all letters we need to write. Minus 1, 1, 0, 1, 2. This is the letters we will get here. Next one we have equation is what? X square minus 3x plus 2 is equals to 0. So what we will get the elements for this? X square minus 2x minus 1x plus 2 is equals to 0. In this both I'll take x common, I'll get x minus 2. Next one I'll get minus 1 common, so then I'll get x minus 2. Now I'll take x minus 2 common, so then what is left over? X minus 1. Now I'll equate both also with 0, then I'll get this minus 2 will become plus 2 and this minus 1 will become plus 1. So therefore I'll get 1 comma 2. So therefore we can say B set is what? 1 comma 2. Is it we have same? No, we have extra elements here. So therefore we can say A is not equal to B. So it's not equal, therefore we'll say it's not equal because it won't have a equal elements. Once again I'll explain. So here we have a first example. So we got a letters as A, L, O, Y because 2 times it's repeating means we can't write 2 times. So therefore I'll write only 1 time. I'll get A, L, O, Y. Here also L, O, Y, A I got. Same elements are there. So therefore I'll say A is equals to B. And it is an equal set because it has the same elements. You can write the answer like that. Next one we have A is equals to N is to N, belongs to Z, and N square less than or equal to 4. They not said N belongs to N. Belongs to N means we can write only positive numbers. But we have a Z. What is a Z means? We have a positive and negative integers both also. So therefore, what they said less than or equal. Properly need to observe. If we have equal, then only we will write plus or minus 2. But we have less than or equal to 4 means we need to write in between elements what and all it will exist. So therefore, we take an n square less than or equal to 4 means square root of 4 we will get plus or minus 2. That means the numbers what and all exist between this and together with that numbers, what we will get minus 2, minus 1, 0, plus 1, plus 2. So I return that. Next question what we have, x belongs to x. So x is to x belongs to r. X square minus 3x plus 2 is equals to 0. By simplifying I got x is equals to 1 comma 2. So I let that also in a set. So then we observe only 2 elements are equal, other 3 elements are not equal. So therefore we can write A is not equal to B because they don't have equal elements. I hope you understood today's introduction. So next class we will learn about the exercise 1.2 sums. If you like this video, please press the bell icon for more like these videos and like and share with your friends. If you have any doubt, please comment it below, and thank you. Have a nice day.